Hello everyone, this video is about the law of refraction. Let's learn its statement and applications in real life. Stay tuned until the end because we're going to solve a practical problem. So what is refraction? Well, refraction is the changing of a light ray's direction when it passes through different mediums. You can see it clearly here when you see the light passing through the glass. Okay, it changes from air to glass, the different mediums, so it changes its direction, and the same when it leaves the glass. Another example is if someone's watching a fish here in a tank, you're seeing the reflection of the light here, right? So the light is actually passing from water to air, so it's changing the direction. You think you're seeing the fish here, but it's actually a little bit down, alright? One thing that we have to talk about when talking about refraction is the index of refraction. So the index of refraction is this thing here, is the speed of light divided by the observed speed of light in the material. Okay? The speed of light in vacuum is the maximum speed we have, but when it passes through a type of material, a medium, it's a little bit slower. So it changes the direction. Okay? And we measure this by the index of refraction. So each medium has a different index of refraction. For vacuum, we have the speed of light over speed of light, so it's 1. And then all the other mediums, for all the other mediums, the index of refraction is higher than 1. Okay, because we cannot have anything faster than the speed of light. Okay, depending on the material, we have different index of refraction. For water, for example, what does this number mean exactly? Well, the index of refraction is 1.333 for water at 20 degrees Celsius. So it means that the light travels 1.333 times slower in water than in vacuum. Okay, so see that I put the temperature here because it actually influences the index of refraction. Okay, so let's go through the law of refraction now. This is the expression used for the law of refraction. So let's go back to the example of the fish before. Okay, so according to the law of refraction, both of these angles times the index of refraction must be equal. So we have the index of refraction of the air times the sine of the angle it hits the water, okay, equals the index of refraction of the water times the angle it hits the air. Okay, actually here is the opposite, right? So we have the our light ray coming from the water, okay, and when it passes through the air, we have another index of refraction in a different angle. Okay, so basically we're just relating the index of refraction, and the angles. Alright, now it's time to put it to practice. Okay, let's use the same example, a simple one, but now we know that this angle here that we are looking at the fish is 60 degrees, and we want to find the second angle. Okay, so we can just apply the law of refraction. We know that this is air, here it's water. Let's assume that air and water are at 20 degrees Celsius. Okay, so we have the index of refraction from the table. We can simply isolate the sine of the second angle, insert the values, and find that the second angle is 40.5 degrees. So see that this angle is smaller than the first one, okay, because, well, the light is traveling from this medium here that has a higher index of refraction and going through a medium that has a lower index of refraction. Every time it happens, the angle increases. For the opposite situation, the angle would decrease. Okay? Okay, now it's your turn to think about everything we've seen in this lecture. So, one thing for you, it is known that the index of refraction increases with density. Alright? So based on this information and on the law of refraction, how would you explain the heat haze effect that happens on a road during a sunny day? Probably you've seen a road like this in a sunny day and you see that the light here is a little bit different, right? This is called the heat haze effect. So how would you explain this effect based on this information? That the index of refraction increases with density. Remember that the temperature, pressure also can change this index of refraction. So think about it and write your answers in the comment sections. See you later.
Thanks for watching. Don't forget to subscribe and turn on notifications to always get the newest videos straight to your feed.